We're going to be talking about stress in structural mechanics. Now, what is stress? I'm going to define several kinds of stress. The first I'm going to describe is compression. I got a sponge, and this sponge is now under compressive stress. I am applying compression. Now I'm going to define torsion. I got a sponge, and I'm going to apply torsion, twisting it. This is torsion. Very good. I'm going to describe now tension. I got a rubber. Now is under tension stress. Bending. I got this, and I'm bending it, and that is bending stress. Shear stress. I'm going to use the samples here now. The first is more or less shear is this. I put this cardboard under shear stress and actually cut it. That is shear. But I'm going to explain it more like we would do in structural mechanics. So, a little bit of room. I'm making this drawing here. Now I got a screw. Let's imagine this screw is holding two plates together. Okay. Very good. We got two plates. And let's imagine we apply these forces like this. Yep. Now this force opposes this one and is creating here in this part of the screw shear stress. And what is going to happen is similar to this. That's what's going to happen to the screw here, and that is shear. So we got compression, tension, torsion, bending, and shear. Easy to understand. Now let's talk about stress. Stress is actually something that we can measure, and we measure it as a force over an area. Now, the international unit system, we use the Newton square meter. And that's how we are measuring stress in international units. Now, I have to say something. So if we drop 1 kilogram of mass 1 meter, it's going to acquire a force of 9.8 newtons because it's related to the gravity pull. Now, we could say that if this sponge was going to be 1/10 of a kilogram, more or less, and I was going to place it on a table that is 1 square meter, that means 1 meter for 1 meter, that will be the equivalent of 1 newton per square meter. Now, that's a very little weight for such a big area. So we use a different unit to measure in structural analysis. Now, I want to say one thing. 1 newton per square meter is actually a Pascal. Pascal. Okay? Now, the most useful unit to use in structural analysis will be 1 million Pascal or 1 megapascal. I'm going to write it here. Mega Pascal equals 1 million Pascal. And 1 Pascal equals 1 Newton. 1 Newton square meter. Now, I haven't seen Pascals being mentioned much in UK, and what I have seen more often is the following: 1 Newton per square meter, 1 kilonewton per square meter, 1 Newton per millimeter square, 1 kilonewton per millimeter square. Now, let's say I got a table which measures 1 meter by 1 meter. Okay? If I put 100 grams or 0.1 kilograms on that table, more or less, and I'm saying more or less, I am applying a compressive force to that table of 0.1 kilogram. So, as I said, more or less the weight of this calculator, well, that's over a 1 meter square table as a compressive force. Now, that's not a lot. So maybe we want to use the kilonewton per square meter. That means if we do 1,000 newtons per square meter, it's like having 100 kilograms over a table that is 1 meter square, which is like a heavy person, not an average person, but quite a heavy person standing on that table. Still, the table is not going to collapse. Now, 1 Newton per millimeter square, that is actually a huge amount of force. And I'm going to explain why. And I need for that a diagram. And I'm going to come here and I'm going to draw a square. Okay. We got the square, and I say this square measures 1 meter by 1 meter. So 1 meter times 1 meter equals 1 meter square. That's what we got, 1 meter square. And that is the table we're talking about, and that's the table where we had one heavy person standing on and all that. But we're going to have now millimeters. And I'm going to say that 1 meter has 1,000 millimeters. 1 meter equals 1,000 millimeters. So 1 square meter is going to have 1,000 millimeters times 1,000 millimeters, which equals 1 million millimeters. Now, if I am applying to 1 square millimeter, that small part there, that very little thing, 1 Newton of compressive force, that is 1.1 kilogram, then we are applying over an area of 1,000,000 millimeters 100,000 kilograms. Now we're putting on that table 100,000 kilograms, but if we do 1 kilonewton per millimeter square, we are multiplying this by 1,000. So we're doing 100 million kilograms. And these are the units we're going to be looking and using during our exercises. So I think it's clear what stress is. Compression, torsion, tension, bending, shear, I explained with examples, and how this force is spread over an area and how this escalated from being 1 Newton per meter square to this unit that actually measures a lot of stress by being 1 kilonewton per millimeter square. If that was a table, this table, measuring 1 square meter, we will have to put on top of it a mass of 100 million kilograms. Certainly the table will collapse under that compression stress. And this is the end of my first lesson.